Advent of Code 2018, Day 7. Let's do this. The sum of its parts. You find yourself standing on a snow-covered coastline. Apparently you landed a little off course. The region is too hilly to see the North Pole from here, but you do spot some elves that seem to be trying to unpack something that washed ashore. It's quite cold out, so you decide to risk creating a paradox by asking them for directions. Oh, are you the search party? Somehow you can understand whatever elves from the year 1018 speak. You assume it's ancient Nordic Elvish. And why is that a link? Oh, that's just a link to the previous day. I thought there was some Wikipedia page on ancient Nordic Elvish. All right, so what are we doing here? We're trying to build a sleigh. And then we have instructions that tell us this. Oh, okay. So we have a graph, basically, that we need to solve. All right. Let's get our input. 2018, Day 7. There's 101 instructions. And they all look like this. So these should be easy to parse out, at least. Problem is asking what order should the steps for your instruction be completed. So it seems like we just need to create a little graph and then step through each entry in the graph as we do them. And we have some rules here. Only C is available, so it's done first. Next, both A and F are available. A is first alphabetically, so it's done next. Then even though F was available earlier, steps B and D are now also available, and B is the first alphabetically of the three. Okay. So that's why we have C, A, B, D, F, E. All right. Let's create our template. (1807). This here, 7. Make a 7 there and say Monday 07 T. And that builds, and we have unsolved. Git commit, add source, git commit -8 2018 Day 7 template. There we go. So we're going to create a graph which has antecedents and a value that gets completed, right? So for step C, we can say it needs A and F to be done first. So how would that look? Struct node. Me is char, and prereq. That's going to be hard to type every time, isn't it? Hash set of char. Will that be sufficient to solve the problem? Let's find out. So let lines equals AOC lib read lines input 2018-07.text for L in lines. We can split on white space and just grab 1, 2, 3, 4, 5, 6, and 7. 1 and 7. Let words equals L.split collect. Expected arc curly. Is that because I'm missing a comma there? Oh, this curly. Okay. And so it's words 1 and 7. So we need to create a map here. Let's call it graph. We can do a B-tree map because that sorts by keys, which is going to be char and node. Or maybe we don't need this then. Hikaru says there's a method called split by whitespace that you may want to use. I vaguely remember that. Does that... Let's look for whitespace. There's split whitespace, split ASCII whitespace, and then split whitespace. Right? And that handles all sorts of white spaces, right? In this day, we have single spaces guaranteed, but there's no reason why we can't do it, right? Right? It's still going to be a vector stir. Yeah, I can go with that. Right, so I was going to say, well, we can do a let E equals self graph entry of words of 1. Oh, we want to grab the character. We don't want a string-based thing here. So we can say let node equals words 1 dot chars dot next dot unwrap, and that'll be a char. And then we can say let prereq is equal to words of 7 dot chars dot next dot unwrap, right? And then we can say the entry of node or insert hash map or hash set new. And then we can say e dot insert Can we? That's an entry. Oh, we don't have the thing yet. Okay, let's build it. Return type of something. Oh, we have to create a new node, right? Default. Oh, can you default on char? I guess you can. I wonder what the default is for char. And now E is a node. So we can say E dot prereq dot insert prereq. And then we can dump it all out. We'll just dump them. There's 101 of them, so it shouldn't be too bad. Actually, there's only 26 of them, right? Because it's the letters of the alphabet for these guys. Self graph. Yeah. So node A, I never set the me's. I think we can get rid of me. There's no reason to have it as a node. We can just make it as a hash set directly, right? So A has a prereq of Z, P, and M. B has a prereq of Z, P, I, E, and Q. So what we need to do now is look to see which letters don't have any prereqs. A, B, C, D, E, F, G, H. All right, what we can do is we have it completed, which a hash set char, and we can, I guess we can initialize that to all the letters. But here's what I'm trying to do is come up with a list of all the letters that are possible, right? And then we're going to just insert that. Possible insert node, possible insert prereq. And we do that, and we can say println this. Oh. Here. All right, so this is a set of all the possible letters. And it's probably all of them, is my guess. But I don't want to assume, right? I want to get them from the input. So now we have a list of all the possible nodes. Should I put that up here? What we can do now is look to see which entries are not in the prereq. And those are the ones that are ready to be done. Right, so this is part one now. Part one, we say for n in self graph, and n should be it's a char node. If node is empty, then the possible, and then we leave it in the possible. So if n node, sorry, n, do we need it? If node.prereq, all I'm trying to do right now is determine which characters are possible to do because they don't have any prerequisites. So what I actually need to do is self-graph keys, right? And those are not possible to do yet because they have prerequisites. So I can say self possible remove ch, and then println here ready to work on. And we can take a look at that list and see if it worked. Possible. Should I do this with test input first? Okay, so this is what this is saying is that E can be completed. So we can take a look at the input and look for a capital E. Oh, see, this didn't work. Step C must be finished before step E can begin. So that means we're not ready to work on E. Okay, so what did I do wrong? Cipher Bernard says means E is the end task. That could be. So I want to flip this on its head, maybe, and say for a node in values. And we can say for ch in node prereq. I have to spell it right. Iter. Now, okay, now this is saying S, J, N, and V are ready to be worked on. All right, let's take a look at the input again. Look for capital S. Step S must be finished. Well, capital S is going to be everywhere at the beginning of the letter, beginning of each line. But we can see 1, 2, 3, and yes. Okay, so that was it. So we need to look at the values and take all the prerequisites out. So now, oh, possible needs to be a B tree set because I want to look at it in alphabetical order. Yeah, and there we go. Now it's alphabetical. Okay. because that was one of the rules, was we had to do it alphabetically first. All right, so now all we need to do is loop over the possibles. B-tree set, I'm going to look it up because it used to be, it had a pop first, but it was nightly only. And hopefully that's made it into stable now. Yay, it's stable as of 166. Okay. I've been using Rust a while if I've been using it before 166, right? All right, so we can say while let some item is equal to self possible pop first. Right, while there's some work to do, we can now say item is done, quote unquote done. So now we want to loop through all of the prerequisites. And I'll loop through the graph and say, okay, we finished this graph item. Oh, first we want to, that's right, we're trying to get the answer. The answer is going to be the order that the instructions are completed. So this is now completed. So now we can do that. Let mut completed equals string new. And we just say item should be a char. It would be a char if I actually popped the correct thing. There we go. So we say completed dot push item, and then this becomes completed. And this should just give us JNSV for now, because we haven't done any more work. Yeah, all right. So to complete an item, we need to loop through all of the nodes in the graph for node in self graph. Oh, but we have to modify. How's that going to work? We should be able to modify node. Can I do that? Will it let me do that? Self graph iter mute. Can I do that? And then we want to say if node.prereq.remove of item, I might have to borrow item, then we might have completed it, right? Or we could just say this, remove it, and then say if node.prereq is empty, right? We've just removed, yeah, I do have to borrow it, okay. We've just removed the last item from here. Oh, no. We do want to do it only when we remove the last one. Okay, so does remove return true and false? It does. If the set contained an element equal to value, removes from the set and drops it. All right, so if, can I say and? I don't know if I can do that because this is borrowing it mutably and borrowing it immutably at the same time. We'll find out. If we were able to remove it and it is now empty, we can now add self-possible insert item. That didn't work because they're still getting JNSV. We don't need the character. Oh, that's what we need to push here, right? Because we just finished this guy. Still JNSV. Wow. All right, well, I guess we start outputting stuff. Println working on item. Println found, let's do this, it in ch. Yeah, I'll break this up now. like that. And then we can say println ch is now complete. All right. So it's not finding anything to remove. Okay. This. Okay. So working on J. Oh, J is done. Do I have this backwards? Oh, am I being an idiot here? Yeah, so step J is done. If step J is done, then all of these are ready to be... Oh, I probably need to do this the other way around, right? Because nothing's found, because by definition they're not prerequisites, right? J is done, which means that Y, I have to keep track of the counts for each one. For each letter, I need to say, okay, this, I'm going to have to redo all of this. Wow. Is there a way I can keep my current data structure? What this is saying here is J's done. So that means Y, the prerequisite for Y is gone for J. But we don't know what the other ones are, right? We would have to scan all the other ones to see where else is Y, right? And where else is K and I, right? Here's another I, for example. So X and J would have to be completed before I could be done. But we don't have that information stored anywhere. This is saying I has to be completed before E can be completed. We know that J is complete. Yeah, I'm trying to think if there's a way we can do it using the current thing, but I think we have to keep track of counts for each letter. So instead of storing it like this, we're going to have to increment a count for each letter type. For each letter, we have a count of items. Can we stick that in the node? Right, we'd have to look that up. We'd have to look that up the other way around, right? Let E equals self graph entry prereq or insert 0. E dot count plus equals 1. I don't even know what that's going to do. Now we have counts. So this has a 6. So I see 1, 2, 3, 4, 5, 6 A's. So that means as we complete it, right, we have to subtract 1 from the count. So J can go to K and say, you can be subtracted by 1. Oh, and then it can be done. And then once that happens, then K is complete. Okay. working on J, completed push item. And then we're going to iterate over the graph. Oh no, we're going to iterate over the prereq for J. That's what we're going to iterate over. All right. For P in self graph. Oh, okay. Get item unwrap. That's a node, and now we're going to loop over the prereqs. Those are just characters. Now we're going to go to those inside the graph, which might not be possible because we just grabbed a reference to this guy. We need to be able to update the other entries in the graph. It's still a reference? I thought I could clone it. I can't do this, right? Oh, I didn't. Oh, because I can't clone it. Why didn't it complain before? There we go. Okay, so now we have a copy of the prereqs. And now I should be able to modify the self graph. So now, Spartang says, I thought Advent of Code doesn't start until December. You're right, it doesn't. I'm doing the 2018 puzzles as a warm-up for 2023. And this is already giving me heartburn. So, okay, so now we've finished the prereqs. We have to loop over the graph. Self graph. Intermute. And we need to modify. We have to subtract 1 from the count. Oh, I don't see it anymore. Anyway, it's there. If G dot. Oh wait, what was G? Okay. If node dot count, so we can say node dot count minus equals 1. Let's get rid of all that. All right. And then we can say if node dot count is equal to 0, then we finished I still want to print those out, don't I? So I can see everything. Println debug out self graph. There. So node count minus 1. So we're working on J. Hij here. And its count is 0. So as soon as K's count becomes 0, then we can add it to the working queue. Self possible insert ch star ch. All right, well, it came up with an answer, but I don't think the answer is right because I want J, B, A, C, D, E, F, G, H, I, and so on. So that can't possibly be it. What can we work on? He says working on item. ready for CH. Crimson Kinda says, funnily enough. What's that? And then we can say CH reached. Oh, I have two CHs here. Let's say finished here. I don't know if that's going to make a difference. Reached 0. Let's see what this says. B reached 0. Is that true? Did B only have one count? Oh, I'm doing this completely wrong. What this is saying is B has one prereq. Let me see if that's true. Capital B. It does. But this saying step C has to be finished before B can begin. Oh, because I'm saying that Y. Oh, I'm looking at the wrong one, right? I should be looking at capital J. Yeah, I'm looking at the wrong thing. I shouldn't be saying if Y is done. This is getting J, right? So prereq is J. I misspelled that. Okay, that's fine. So it's Y, K, L, I, and A. And each one of those can get subtracted by 1. So Y gets subtracted by 1. Oh, I'm just doing everything. I'm being dumb. What I want to do is say self E equals self graph entry of finished. Like this, right? Get mute. Can I say get mute? Unwrap. Node. All right, so we got this node ready for Y, and then we can just say, and that's a node, we can say node.count minus equals 1. And we can say if node count equals 0, println finished. And we can just print it out here, right? Node count. If node count is 0, then we're going to add it to our completed self possible insert node value finished. Okay. I think it's working better now. The Y did reach 0 somehow. It's a different answer. I'm just going to give it a stab in the dark and see if it worked. Hey, how about that? It worked. All right. So we can get rid of all these printlns now. Println, blow it away. Oops. Why it insists on being down there, I have no idea. Okay. All right, so that's part 1. Good. Git commit -am 2018 day. Oh, you know what I didn't do is this. Okay. Okay. Git commit -am 2018 day 7 part 1. My goodness. Ziffer Bernard says iterate over prereq instead of the whole graph. Yeah. So I finally got there. Sorry I didn't see your comment sooner. Spartan says, with Rust, you use GDB, or does it have some other debugger you can use? You can use GDB. I'm not a user of GDB because I use println debugging. Second 4 is useless. You just need to get back the node from prereq. Is it? Because prereq is a set. So I want to go through the whole set and make sure that I hit the down counts. So I'm not sure what you mean. Crimson kinda says, is git-am, is that for a append message? No, yeah. I wish git were better. But git commit-a means take all the untracked files, not untracked files, but the unadded files and add them. And then m just is message. Oh, Cipher says that was before I found my error. Okay. Sorry about that. All right. Part 2. Let's do part 2. I got 20 minutes, which based on the amount of time it took me to do part 1, I don't think I'm going to be able to do part 2 in. As you're about to begin construction, 4 of the elves offer to help. The sun will set soon. It'll go faster if we work together. Now you need to account for multiple people working on steps simultaneously. Oh, goodness. If multiple steps are available, workers should still begin them in alphabetical order. Each step takes 60 seconds plus an amount corresponding to its letter. So step A takes 60 plus 1, while step Z takes 60 plus 26. No time is required between steps. All right, I think I understand what we're doing. We're making a queue and having up to 5 workers. So I think what we need to do is something very similar to this, except we need to be able to continue popping with 5 workers and 60-second step durations described above. How long will it take to complete all the steps? So we just need to keep track of time with 5 workers, right? Did I read that correctly? 5 workers? Oh, yes, with 5 workers, 60 seconds plus. What's the final time after we're all done? So now instead of just popping off the possibles, we need to create a B tree set with a time. Or B tree map with a time. I don't think this needs to be a B tree map, but I'm going to leave it alone. How are we going to do that? And that'll be the time it completes. And then when we pop that off, we know what the new time is, right? Let mut q equals B tree map new. This seems like we should be doing this up above, right? Because that way it's ready. Oh, and then we're modifying it here. Okay, we should clone it then. Let's move it up here. And then say let mut possible self possible clone. That way we can reuse it for part 2. Right? Yeah, the other selves are the graphs. Okay. And now what we can do, yeah, let mut possible. We'll clone it again, even though there's no part 3. let total time. Do we need that, or did we just pop that off? So now we want to create a new queue with all the possibles that are in there, with the key being the time. So for p in possible, queue.insert, and it's going to be just the characters. 60 plus p, that's a char already, right? Yeah, as, I don't know, I32, I64. Can I do that? Minus a as I64 plus 1, comma, p. And then println p. Oh, this doesn't need to be. All right. So it's showing that a T70 will finish J, a T74 will finish N, a T79 will finish S, and T82 will finish V. So now we need to have up to 5 workers. And basically it's this loop pulling off of the work queue and inserting into the work queue with the next time, but 5 at a time. I should not have started this problem. I should have been smarter. Because now I need to finish it, but I'm almost out of time. Let's see if we can do it. Let's keep a worker count. Let mut count equals 0. Let's call it worker count. Why not? And what we can do is say while worker count is less than 0. Sorry, less than 5. Right? We need 5 workers. We're going to pull off the next one at time t equals whatever and work on it. And then add that to the queue. Is that sufficient, or will that mess us up? Let next item is equal to queue dot pop front first. Sorry. We don't care about completing it. We're not saving the order in which we complete them. We're just saving the time. So now next item of unwrap. I can say this, if the queue is empty, then we're done. All right, let's do that way. If let sum next item equals that, then we're going to do our work. Otherwise, break. We're done. Okay. So we have an item to work on, and that's a tuple, right? Oh, I left the unwrap in there. Here it is, I64 and char. So time, an item. Time and item are anagrams. How about that? I never noticed that before. All right, so now we're at time whatever. We're going to have to save that time somewhere because we're going to need it for the next thing. Let most recent is equal to 0, most recent equals time. And now what we want to do is say, take this item, do this work on it. Oh, and we've modified our graph too. We've modified all the counts and everything. We need to reset all the counts. Okay. All right. I just wanted to build it to make sure that part 1 didn't break. It looks like that's the same. That's the right answer. Still. MPZIUE? Yeah. Okay. It's going to, I can't just steal this order though, because it's going to be a different order based on the fact that we're now time based. We do want to grab the prereqs, right? So I think this code still stays the same, right? And then complete them. The only thing is that when we complete it, instead of inserting it into possible, we're done with possible now. We actually have to insert it into the queue using this formula again. Right? And then this most recent. It's not P anymore. What is it? It's finished. That says 65. That can't be right. That's the answer it came up with, was 65. That is definitely not right. Oh, well, first of all, I'm not incrementing the worker count. So worker count is always 0. Wait a minute. So why is this even ending? I'm trying to figure out why it's ending. Because we have, here's the queue, right? We can say first item to work on is item t equals time, right? We can look at that. Oh, it's the current time plus 60 plus blah, 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 blah. Got it. That means, okay, we have 1, 2, 3, we have 4 things here. And I was thinking, okay, well, we can only insert up to 5 things here, but fortunately, right? All right, so we're item to work on is time, but this needs to add our current time, whatever time it is right now. So this should be called current time. I should have used the rename. Okay, so now these are increasing directly. All right. Println completed item finished. All right. We're getting an actual time now, right? 7:55. Is that the right answer? Hey, that's the right answer. Okay, so I was able to do it after all. I was really worried this was going to just be too much of a struggle. We don't need worker count. That's interesting. I never even used worker count. I just did it. How could that be right? That means I can just do this. They can't be right. How can this be giving the right answer? We're not taking into account the number of simultaneous workers. I guess it doesn't matter. Yeah, Siffer Bernard says, I didn't understand your solution, but it seems cool. I don't understand it either, because it doesn't make sense that it would work, because we don't care here anywhere about how many workers there are. All we're doing is adding up to the next time and inserting the next value and making sure that, however long it takes is however long it takes. That means I can remove this assert too. I am really puzzled. I'm going to have to think about this. Sylvia Bernard says, maybe it doesn't matter because you can never have more than 5 possible tasks at the same time. Well, that's certainly something we can check, right? Println remain task count. Q len. Run. Yeah. We never go above 5. I wonder if there's different input that actually does go above 5 and that would catch somebody out. Which would be a shame, because if I were to implement a limit of 5 at once, how would we test for that without an input that goes above 5? Anyway, this is working and I'm out of time. So git status, git commit. 2018, day 7, part 2. We're done. Let's take a look at my commits here. Oh, and thank you very much, Cifra Bernard, for the follow. Much appreciated. Refresh. Oh, I didn't push. There we go. All right, I'm going to try to stream again tomorrow, and we'll work on day 8. I'm not going to peek, but we can take a look at the advent calendar. We can see Santa's hat's all done. Now it looks like we're filling in a sleigh of some kind. Neat.